Hello pre-calc students, this is Mr. McAllen and this is a third video of Mathematics of Finance. So what we're going to talk about today, or in this video, is annuities and future value. Most of the problems we've done so far is considering that you're given, well this looks like a pumpkin, but you're giving, let's just do a bag of money. You're given a bag of money and you invest it for a period of time and you hope it grows into a really big bag of money. So most of the time, we don't get a lump sum of money dropped into our laps and then invest it for a period of time and not put any other money into the fund. Typically, we start out with an investment where we're going to put a certain amount of money away every month or every quarter or even every year and let it grow, and then hopefully match that amount of money each year as part of our investment strategy. So what we have here is a scenario where we're putting money away quarterly. Sarah has decided to invest $500 every quarter, and her bank promised her a return of 8% interest for the life of the investment. How much would her investment be if she invested this rate for 10 years? So let's look at the idea of this. It starts out where on day one, this would be at time equals 0, she puts her $500 in. Then at time equals, let's say, 3 months, she has her 500 that she puts in again, but she's had in the account 500 times 1.02 to the first power. Now the reason why it's the first power is because it's the first quarter. The reason why it's 0.02 is because it's 8% divided by 4 for 4 quarters. Let's say we're at 6 months now. We have 500 that she invests today, plus the 500 from 3 months ago, which is at 1.02 times 1 investment cycle, which is a quarter, plus the 500 from the very beginning of the investment, and that's for 2 investment cycles. You can see that this progression is going to keep going and going. Now we're at 9 months, and she's got 500 plus the amount from last month, 1.02 to the first power, plus the amount from the last quarter before that, 1.02 to the second power, plus the amount of 500 from the very first, when she opened up the account. This would be 1.02 to the third power. Well, we could keep doing this forever, and let's say that we want to figure out what her amount would be after 10 years. Let me spell years right. So what happens is we can keep doing this and we would have 40 things to be added up. But instead of doing it this way, we could simply just, there's a future value equation that is in the book, and it's something that we use as a shortcut. And the way the future value equation works is if you want to find out the value that's in this lump sum of money at the end of a certain amount of time, you would put for R 500, because that's the amount that your monthly installment or your quarterly installment, and you multiply it by the quotient of these factors, and it'll be 1 plus the 0.02. Now remember, this is where people are going to make a mistake, because I is the 8% divided by 4 for quarterly. If we were just going to have 8%, let's say we're going to do it invest monthly and 8%, we would want to make sure we divide 8% by 12. So that's going to be 1.02 raised to the, because it's 10 years and done quarterly, you've got to say 10 years times 4, which would be 40 installments. So this would be 40. And then we're going to subtract 1 and divide it by the adjusted interest, which is 0.02 again. When we do this math and we write it all out, the future value of this investment becomes, I think I calculated over here, $30,201. And that's how we would calculate or compute what our final or future value of this money would be. I'm going to pause the video because I'm going to get, we also want to figure out what present value is for some scenarios of money, and that would deal with if we were doing mortgage installments. So I'm going to set that up, and then I'll be back and we'll finish this video up. Okay, so I'm back, and now let's consider the talk about present value. With present value, let's say, for example, that you want to buy a car for $18,500. You're going to put $2,000 down because the bank requires some sort of a down payment. So that means you're going to finance 16,500. How does a bank figure out what your monthly payments should be at a given interest rate to make sure that you're paying off this present value? This is called present value. So that by the end of the mortgage payment, that they're not left at a deficit or you didn't overpay. And this is where the present value annuity calculation comes in. So I'm going to just look at the equation from our book, and it says present value is equal to, and the formula is a little bit different, but it basically has the same general look. R represents your monthly payments. And in class, I'll show you how they derive this formula. It's actually pretty interesting, but it's not worth the time in the video. And but it basically, just be careful about these slight differences. 1 minus 1 plus the interest rate. Now remember, this interest rate is your annual interest rate, but it's normalized. Like for monthly payments, you would divide it by 12. This would be N, the number of payments that you're going to make. So if it's like a 4-year car loan, then N would be 48 because there's 12 monthly payments. 4 years, so that would be 48, all divided by, again, that interest rate that's been converted to a monthly interest rate. So how do we figure this out? So the present value of the car you're buying, the bank would put in 16,500, and we're trying to solve for what your R value is, the monthly payment, so that at the end of this cycle you have satisfied the loan with interest. So we put in, now the interest rate, I didn't put that down. Let's say that the bank gives you an interest rate, because there are sweet interest rate deals, and I'm looking at a, let's just look at a realistic, they say the APR is 2.9% annual, so we'll say 2.9%. So what that means is, you would take that for the I calculation, 1 minus, this would be 1 plus, remember it'd be 2.9 divided by 12. I need to calculate that, so 2.9 divide that by 12, and that gives us an interest rate of, I should do 0.029 divided by 12, and that would be 0.0024. So this would be 0.0024. I'm going to say 2, round up, if I don't want to cheat the bank. And that would be for 48 payments, and I would have to divide that by 0.00242. And when I solve for R, so what I'm first going to do is I'm going to find out what this ugly looking fraction value should be, and I'm just going to divide 1600 by 16,500 by that. So let me do that in the calculator. So I'm going to go to my fraction bar here. I'm going to do N over D, and I'm going to put in 1 minus, and the fraction 1 plus 0.00242 raised to the 48th power. And I'm just going to arrow down to the bottom. I'm going to put in 0.00242. And when I compute that, I'm going to get, I got a negative value. Let me make sure I wrote down that formula right. And, oh, this has to be to the negative power here, negative 48th. So that should be negative N. So let me fix that. It's always important to obviously write these formulas in correctly. So this will be to the negative 48th power. Let's get up to the exponent spot. And I'll insert that negative sign. And then when I calculate it, I get 45.265. So it's R times 45.265. So that is 16,500. And So my monthly payment on this car should be 16,500 divided by 45.625. So my monthly payment will be, let me do 16,500 divided by 45.625. And that says that my payment would have to be about $361.64 monthly, so that I would pay back that amount over 4 years. So hopefully this scenario has helped you understand how the bank comes up with they basically use a present value calculation based on what you're going to borrow today, what your payments should be monthly over how many payments. Now this is really applicable to figuring out a mortgage. For instance, if the house you're going to buy is $200,000, present value would be $200,000. The R would be what you're calculating for your monthly payment, and the I amount would be what the interest rate would be for if it was a monthly interest. You would take, like, let's say they're going to charge you 3% interest, which would be a really great deal, but you have to make sure you divide that by 12 for monthly payments. Don't forget that negative sign that I forgot, because that will definitely show you an incorrect value at the end. As I saw, I got negative values. So that told me there was something wrong. So it's always good to kind of like double check your work as you go through these complicated formulas. Again, I'll show you in class when I return how we come up with this present value formulation. But all the same, this is all you really need to get through the problem work that we have for you in class.